Around 1995, I wrote a program to emulate an 8-bit computer, a very simple 8-bit computer. I was doing it as a project for a night school class I was taking when I was studying for my computer science degree. I wrote this simulator and a compiler in Borland C on a Windows computer. And then this year, 2021, back in June, I decided to try and port that code to a Linux computer and the GCC compiler. And that's what you're looking at here is the main menu of what I called Jay's 8-bit computer model. I'm just going to go through the first 3 menu items just to introduce you to the computer model, give you an idea of what it's all about. So we'll take a look at the front panel, pressing 1. And the computers I worked on in the late 70s and in the 80s, I was computer maintenance. And those computers typically had front panels with rows of lights and switches to set bits and different registers. And that's kind of what I based this front panel on. What I have in the upper right is the program counter, and that points to the instruction that is loaded into the instruction register. The instruction register will decode the different bits that are turned on and perform whatever operations um, those those bit patterns define. Next is the stack pointer. I'm not going to go into the stack pointer in this presentation. I'll do a different one to demonstrate that. We'll go to look at the memory address register. Most of the instructions, I have 32 instructions as part of my instruction set, and most of them have some type of operand or an argument to go along with the instruction. Typically, the instruction register will have the instruction, and then the memory address register will point to the memory location specified in the argument that goes along with that instruction. It'll make sense as we kind of go through it. The processor status word has the 4 flags. The high order bits are different flags for different conditions that can be used for conditional type branches or subroutines or that sort of thing when programming the computer. The accumulator then is the central part of the CPU. It's an accumulator-based CPU. Arithmetic and logic operations are performed on the data that is loaded into the accumulator. Down here then we have the X and Y registers. Those are just general purpose registers. And then I'll move on to the cycle indicator. An instruction cycle is made up of a fetch where the instruction is fetched from memory and then an execute portion. And when I run programs in here, an indicator will toggle between that fetch and execute portion of the instruction cycle. Then I have a few key options down here. I'll just show you. If I press the P, then the cursor is put into the program counter, and I can move that cursor left or right with the 4 and 6 number keys. And I can toggle bits off and on with the space bar. That way I can put in the starting location of a program. The program counter is the only register that can be edited directly from this screen. If I exit out, then you see down here I have a fetch, execute, step, and run command. I can, depending on how granular you want to get when you run a program, you can use the fetch and execute to run an instruction cycle so that you see the instruction get fetched from memory and then press E to actually execute it. Step will do a fetch and an execute in one key action, and then the run command will run the entire program. C is to clear the registers in the front panel. So I've got that the program counter has something in it right now. If I hit C, it clears it out. If there are other registers had anything in them, obviously the processor status word is the exception, but the other registers would be cleared as well. I'll exit out of the front panel for now, and we'll look at the memory menu. And I'm going to start with displaying the contents of memory. The J8CM has 256 memory locations. When you have a memory address register of 8 bits, then that only allows for 256 memory locations. I display them in 4 pages, page 0 through 3. So here we see 0 through 63. And then if I hit the space bar, we have 64 through 127. And the space bar again, and we have 128 through 191, and then 192 through 255. And you can see that it's all zeros in there right now. If I go to the edit memory, then and I can start. I select the starting location for displaying the next 10 rows of memory that can be edited. Now here I use the number keys again, the 2 to go down and 6 to go to the right, 4 to the left, 8 is up. And if I go down to memory location 8, again I use the space bar and I can toggle these bits. And then if I want to page to the next memory location, I hit N, and I'll go ahead and page to memory location 20, and we'll just go ahead and enter in a program that we can run. If I set this bit, this command loads the accumulator, and then the argument will go ahead and set this bit, which is an 8, and then you'll recall in memory location 8 I put the value of 127, so it was all ones except for the MSB, the most significant bit. If I put in 101 for our next instruction, that instruction will say to load or to take the contents of the accumulator and store it in a memory location. So I can go, whoops, back up here, and I set these bits, and what this will do then is it will store that information that we read into the accumulator from memory location 8. It will store that out to memory location 10. Next, I am going to put in a command to clear the accumulator, and that is the bit pattern to clear the accumulator. There's no argument or operand for this particular instruction, so the next in the next memory location I'll put the next instruction we want to execute. And I'm just going to put a 1 in there. That is for the output command, and that has an operand. So what we're doing here, and I'll go ahead and put for the operand that memory location 10. What we're doing here then is we're taking the contents of memory location 10 and we're writing it to the output stream, which I will show you after we finish here. Then the next thing we want to do is put in a halt instruction, and the halt instruction has an operand, and what I will do is put 20. Is that 20? I think that's 20. Yeah. We'll put 20 into that that operand, and that will load. It will halt the program, and it will load 20 into the program counter so that we could run the program again from the very beginning if we like. I'll exit out of here, and then if I display memory again, you can see that I have the program that we just entered starting at location 20 is now in memory. So we'll exit out of here, and I will show you the I/O panel. The I/O panel is divided into an input stream on the left and an output stream on the right, and you can see we have an I/O marker for the input stream, an I/O marker for the output stream. If I had information, if I had data in the input stream that I was reading into, say reading in with the program or using the bootstrap to load the program into memory, then as each location is read, the I/O indicator or marker would move to the next location to be read. And then on the output stream, same thing, only as we write to the output stream, the I/O marker moves to the next available location. And there are 20 blocks of input and output, and I just go through those with the N key. I don't have to show you anything else on that for now, so we'll exit and we'll go back to the front panel. Now we've got our memory or our program loaded in memory. So to run the program, we go to the program counter and we put in 20 because that's the location of the first instruction in our program. I'll go ahead and exit. Now I'm just going to step through this program, so one instruction cycle at a time, so we can see what happens. So with the first step, we loaded the accumulator with, you see that's our instruction to load the accumulator. We loaded it with the ones. And you can see the cycle indicator is on the execute portion of the instruction cycle. I'll go ahead and step one more time, and now we've done our write of the accumulator to memory location 10. So if I exit from here and go back and look at memory, display the contents, you can see here in location 10 we've written all ones from the accumulator. So essentially we copied the data from 8 to 10. Skip, go back here. Let's go back to the front panel, and we'll go to our next, we'll execute our next instruction. And that is to clear the accumulator. You can see the accumulator is now all zeros. Um, the uh, the program status word has this is actually the zero flag. Once the accumulator was emptied out, it set the zero flag. This is the instruction cycle flag, so that alternates between zero and 1, depending on if it's a fetch or an execute. We'll go to the next instruction. That is the instruction to write that location to the output stream. So I'll go ahead and exit, and we'll look at the output stream now, and we can see that the ones have been written to that stream and the IO marker has been incremented. Back to the front panel, do another step, and we reached our halt command, and the program counter has been loaded with 20 once again. I'm going to go ahead and run it one more time, just do the run, and if you watch down here the fetch execute indicator, you'll see it flash real quickly as I run the whole program. I thought you would, but I guess not. There we go. You might have seen then the indicator, and I think I've run it twice now, so if we go back to the IO panel, we've written 2 more times to that IO panel, and it's moved the the marker. So that's just a brief introduction. I will do some other videos if you're interested in the other capabilities, and I'll show the compiler and some of the other things that can be done with this model. I have the source code on GitHub. Again, it's written in C. The original documentation was an unsupported version of Word. I've since ported that to the open document format, and I've got a repo on GitHub for that as well. I hope you found some value in this video, and I thank you for watching.